All right, so today we're going to be taking a deep dive into the world of AI, and specifically the insights of a real trailblazer in the field. Demis Hassabis,
Yeah.
you probably know him as the CEO of Google DeepMind, and
Yep.
a recent Nobel Prize winner in chemistry.
Oh, wow.
Yeah. But what's really captivating is how deeply he thinks about AI's potential to completely transform scientific discovery. I mean, just completely transform it.
Yeah, he's really at the forefront of thinking about how AI can be used not just for, technological advancements,
Mm.
but also to push the boundaries of scientific knowledge. It's really a pivotal time for AI. We're seeing it move beyond just theoretical applications and into actually solving real-world problems. Just think about the advancements in fields like medicine, materials science, even climate modeling.
Absolutely, and we get a glimpse into his thinking in a recent interview he did with País English. It's titled, Demis Hassabis, Nobel Prize winner in chemistry. We will need a handful of breakthroughs before we reach artificial general intelligence. And what's intriguing is how he balances this excitement about AI's potential with a really grounded view of the challenges ahead.
Yeah, he's not getting swept up in all the hype. He's very clear-eyed about the road ahead.
Yeah.
He's pushing back against this prevailing narrative, particularly among some tech leaders, that superintelligence is just right around the corner.
Yeah, we hear that a lot, right?
Yeah, and Hassabis is arguing that we need a few more, fundamental breakthroughs before we reach that level of artificial general intelligence.
And that's refreshing to hear, right? Because it's not about dismissing the potential of AI, but rather acknowledging that true AGI, where AI systems have the same cognitive abilities as humans, is still a considerable distance away.
Exactly. He's not saying it's impossible, just that we need to be realistic about the timeline. And he uses this really interesting analogy. He talks about needing a handful of breakthroughs.
Yeah.
Which suggests that these aren't just, incremental improvements we're talking about, but rather significant leaps in our understanding of how to build truly intelligent systems.
And that leads us to another interesting point. His view on large multimodal models. He doesn't see them as the sole answer to achieving AGI.
Right.
While these models are impressive in their ability to process different types of data, Hassabis believes we need more than just larger data sets and more computing power.
I think this is where his background in neuroscience really comes into play. He understands that human intelligence isn't just about processing information. It's about reasoning, understanding context, and making complex decisions in ways that current AI systems still struggle to do.
Yeah, it's not just about brute force computation. It's about something more nuanced and sophisticated.
Yeah,
He's not saying that large models are irrelevant, but rather that we need to explore different approaches, focusing on areas like reasoning and problem solving to really unlock the full potential of AI.
Yeah, it's almost as though he's advocating for a more balanced approach, combining the strengths of these large data-driven models with more nuanced techniques that actually mimic human cognitive processes.
And all of this is happening while he's leading AI research at Google. I mean, he's actually merged DeepMind, his company, with Google's broader AI initiatives. This feels like a major power move in the tech world.
Oh, absolutely. It definitely signals a shift in the landscape. With Google consolidating its resources and talent under his leadership, it seems like they're really aiming to dominate the next wave of AI development, particularly with projects like Gemini and their push into generative AI technologies.
And speaking of groundbreaking work, we can't overlook his Nobel Prize win for AlphaFold, which has basically revolutionized how we understand protein structures.
Yeah.
I mean, this is a fantastic example of AI's power in scientific discovery.
It really is. It's an incredible achievement. I mean, AlphaFold tackled a problem that had stumped scientists for decades, predicting how proteins fold into their intricate 3D shapes.
It's so complex.
Incredibly complex, and these structures are critical because they determine how proteins function. Before AlphaFold, researchers relied on these painstaking experimental methods that could take years to determine the structure of a single protein.
Oh, wow.
It was a really slow and laborious process.
So now with AlphaFold, we have access to the structures of millions of proteins. It's paving the way for incredible advancements in fields like drug discovery and disease research.
Absolutely. The implications are mind-boggling. Imagine being able to design targeted therapies based on a precise understanding of protein interactions, or even developing new materials inspired by nature's intricate designs. This is just the tip of the iceberg in terms of what AI can achieve in scientific research.
It's really remarkable, and it all stems from his early work at DeepMind, where they focused on games as a testing ground for AI. Think about AlphaGo, their program that beat the world champion of Go. It was a landmark moment in AI history,
Right.
showing the world just how powerful these systems could be.
It really captured the public's imagination. It was like this turning point where people started to realize the true potential of AI. And, games offer this really interesting controlled environment for developing and refining AI algorithms. They have clear rules, objectives, and ways to measure progress. That's a fascinating analogy. Almost like training AI in a virtual gym before letting it loose on real-world challenges.
I like that, a virtual gym for AI. And Hassabis has talked about how the lessons learned in these game environments can be applied to real-world scientific problems. It's not just about winning a game, it's about developing strategies, making decisions under uncertainty,
But
and solving complex problems.
exactly. And he calls this type of problem combinatorial search, where you have this massive number of possibilities and you need to find the optimal solution. This is where AI excels.
And this brings up a crucial point. He argues that AI is particularly well-suited for tackling specific types of scientific problems, especially those involving this kind of complex search through vast data sets. It's about finding the needle in the haystack, so to speak.
Right, and there are so many areas of science where this applies. Think about fields like material science. We need to discover new materials with specific properties for things like energy storage or superconductors. This involves searching through an enormous space of possible chemical compositions and structures. And AI can significantly accelerate this process, leading to faster discoveries and breakthroughs.
But of course, all of this computing power comes at a cost. What about the environmental impact of AI, the energy it consumes?
Right, that's a valid concern, and Hassabis doesn't shy away from it. He acknowledges that AI can be energy intensive, especially when training large models. However, he believes the potential benefits of AI, particularly in addressing global challenges like climate change, outweigh the energy usage.
So it's about balancing the cost with the potential payoff.
Exactly. He argues that AI can be a powerful tool for developing new clean energy technologies, optimizing existing systems for efficiency, and even driving breakthroughs in areas like fusion energy.
It's an optimistic view. But considering his track record and the progress we're seeing in AI, it's hard not to be at least a little hopeful. But before we get too carried away, let's take a closer look at Hassabis' journey to becoming a leading figure in AI. It's a fascinating story, and it might shed some light on his unique perspective.
Yeah, his background is incredibly diverse. I mean, he was a chess prodigy, a video game designer, and then he earned a PhD in neuroscience. It's almost as if he's been preparing his whole life to lead this AI revolution.
It really does seem that way. And remember, he co-founded DeepMind in 2010. Back when AI wasn't exactly a hot topic, he clearly had a vision.
Sure.
It's remarkable to see how it's all unfolded.
It really is.
What stands out to you about his career trajectory?
Well, what strikes me is this consistent theme of tackling complex problems and pushing the boundaries of what's possible, whether it's mastering chess at a young age, designing intricate video games, or building AI systems that can rival human intelligence. There's this drive to explore the unknown. And now, as the head of AI research at Google, he has the potential to shape the entire field. It's almost like he's holding the keys to the future.
It's a lot of responsibility, but he seems to be approaching it with a sense of purpose and a deep understanding of both the potential and the risks of this technology.
Absolutely.
All right, so we've covered a lot of ground here. We've talked about Hassabis' vision for AI, his groundbreaking work with AlphaFold, and his unique perspective on the path towards AGI. But there's so much more to explore, and I'm particularly interested in digging deeper into his thoughts on the future of AI and its potential impact on scientific discovery.
Yeah, there's a lot more to unpack there.
A lot more to unpack.
It's fascinating how he sees AI as this bridge between the digital world and the physical world. He believes AI can help us understand and manipulate matter at a fundamental level. And this could lead to breakthroughs in areas like materials, science, energy production, even drug discovery.
And he actually gives a concrete example in the ELPS's English article. He talks about how AI could be used to design completely new proteins with very specific properties, something that's currently beyond the reach of traditional methods.
Yeah, it's really remarkable. Imagine being able to design proteins that can act as catalysts for clean energy production or create new materials with unprecedented strength and flexibility.
It sounds almost like science fiction, but the way he talks about it, it feels like these possibilities are within our grasp.
He even mentions how AI could play a role in achieving nuclear fusion, which has long been considered the holy grail of clean energy.
It's ambitious, for sure, but he seems to believe that AI can accelerate the research and development needed to make fusion a viable energy source.
And it's not just about energy. He sees AI as a tool for tackling some of the most fundamental questions in science, like understanding the origins of the universe or the nature of consciousness.
That's a whole other level of thinking about AI. It's not just about building tools or solving problems. It's about expanding our understanding of the universe and our place in it.
And this brings us back to his cautious optimism about AGI. He doesn't believe we're on the verge of creating superintelligent machines that will surpass human capabilities, but he does see a path towards AI systems that can collaborate with humans, augment our intelligence, and help us solve some of the world's most challenging problems.
It's a vision that's both exciting and a bit daunting. If AI is going to play such a central role in our future, what does that mean for humanity? What does it mean for our jobs, our relationships, our very sense of self?
These are questions that we as a society need to grapple with, and Hassabis acknowledges the potential risks of AI, but he believes that with careful planning and ethical considerations, we can harness its power for good.
He's actually quite specific about this in the article. He talks about the need for safe and aligned AI, meaning that AI systems should be designed to align with human values and goals.
He also emphasizes the importance of transparency and accountability in AI development. We need to be able to understand how these systems work and make sure they're being used in ways that benefit humanity.
It's a call for responsible innovation, which is something we're hearing more and more in the AI community.
And it's not just about technical solutions. He also talks about the need for education and public dialogue. We need to ensure that everyone understands the potential impact of AI and has a voice in shaping its future.
It's about democratizing AI, making sure it doesn't just benefit a select few, but rather serves the needs of humanity as a whole.
And that leads us to another interesting point. The global nature of AI development, Hassabis emphasizes that this is not just a Western endeavor. He sees AI as a global technology that requires collaboration and cooperation between nations.
He specifically mentions the importance of involving countries like China and India in the conversation, recognizing that AI will have a global impact and that solutions need to be developed on a global scale.
It's a reminder that the future of AI is not predetermined. It's something we're actively shaping through our choices, our policies, and our collective vision for the future.
So let's shift gears a bit and talk about the specific ways AI is already being used to address real-world challenges. We've touched on some of these, but I'm curious to hear more about the practical applications of AI that are happening right now.
Well, one area where AI is already making a huge difference is healthcare. Like in medical imaging, for example, AI algorithms can analyze scans and detect anomalies with an accuracy that often surpasses human radiologists.
That's not about replacing doctors, though, right?
Right, it's not about replacing them. It's about giving them a powerful tool to aid in diagnosis and treatment planning.
Augmenting human expertise.
Exactly, and this extends beyond just image analysis. AI is being used to personalize treatment plans, predict patient outcomes, and even accelerate drug discovery.
And what about personalized medicine? Imagine using AI to analyze your genetic data and predict your risk for certain diseases or tailor treatments based on your individual profile.
That's already starting to happen. We're seeing companies develop AI-powered platforms that can analyze vast amounts of genomic data and identify patterns that would be impossible for humans to spot.
It's like having a superpowered detective working behind the scenes to uncover the hidden clues in our DNA.
And another area where AI is having a major impact is in climate science. We talked about fusion energy, but there are many other ways AI can help us address climate change.
Yeah, in the article, Hassabis specifically mentions using AI to optimize energy grids, making them more efficient and resilient. He sees this as a key step in transitioning to renewable energy sources.
And beyond energy, AI can be used to model climate patterns, predict extreme weather events, and develop strategies for carbon capture and storage.
About using AI to better understand the complex dynamics of our planet and find solutions to one of the most pressing challenges of our time.
And what's exciting is that this is just the beginning. As AI continues to evolve, we can expect to see even more innovative applications emerge in fields ranging from agriculture to transportation to education.
It's a future filled with possibilities, but also potential pitfalls. It's up to us to ensure that AI is developed and used ethically and responsibly.
And Hassabis really emphasizes that. We need to approach AI development with humility and a deep awareness of the potential risks. He's not advocating for blindly racing towards AGI, but rather for a careful and deliberate approach that prioritizes human well-being.
And that's a message worth remembering. As we stand on the cusp of this new era of AI, it's crucial to have open and honest conversations about the ethical implications and the kind of future we want to create.
He leaves us with a powerful thought. He believes that AI has the potential to be one of the most transformative technologies in human history. And it's up to us to ensure that this transformation leads to a better future for all.
So as we conclude this deep dive into the world of Demis Hassabis and the future of AI, we encourage you to continue exploring, questioning, and engaging in these crucial conversations. The future of AI is not something that's happening to us. It's something we're all actively shaping